So when we were doing 5C, the first thing that we did was we went through here and the teacher gave out these grades. And we tallied those up. We put them in which category they were, if they were an A, a B, or a C. Okay, and we counted, made sure that we actually had 25, added them up. Then we were asked to do our relative frequency, which is a little bit different. So I've just gone down here and I've wrote, well, total number of A's is 4, B's is 7, C's is 9. This is something you're going to have to do for your second project. So I probably would write this stuff down, especially since I gave it to you to write it down on. But I don't know. Okay, so on your second project, it asks you to list these tables. Well, the first thing it's wanting you to do is write your relative frequency as a fraction. Okay, well, there's 4 A's out of 25. Okay, there's 7 B's out of 25. That's how I would write this as a fraction. 9 C's out of 25. 3 D's, 2 F's. Okay. And if I add up every one of these fractions, if I do 4 25ths plus 7 25ths plus 9 25ths plus 3 25ths plus 2 25ths, well, it's going to tell me, or any calculator I use is going to say, well, that's 25 out of 25. That would be my total, which is just equal to 1. So that means that we've got 100% if our fraction is 1. We've got 100% of our data, right? To find the percentage, and we've talked a little bit in this class about how to find a percentage, but what we're going to need to do, and I'm not going to write every single one of these out, but on the first one, let's say I want to find the percentage, you're going to do 4 divided by 25. I'm just dividing my fraction. 4 divided by 25, and that gets me 0.16. Now that is a decimal, right? It's not a percentage, it's a decimal. How do you get a decimal to a percentage? Perfect. You multiply by 100, which is going to get you 16. Okay. So 4 divided by 25 was 0.16, but as a percentage, that's going to be 16%. Okay. 7 divided by 25 got me, I'm just going to write these decimals right here so that this one got me 0.16. I multiply by 100 to get 16%. 7 divided by 25 is going to be 0.28. If we multiply that by 100, we're at 28%. 9 divided by 25 is 0.36, and that's going to be 36%. 3 divided by 25 is 0.12, which is going to be 12%. 2 divided by 25 is 0.08, which is going to be 8%. So are y'all good with how we got that category? Okay, because that's one of the things on your statistics project you're going to have to do with your data is you're going to have to make this frequency chart. So if I add up all these percentages, it should be what? It should be 100% if I've got all my data here, right? If it's not accounted for. Now, there's going to be some times when you might not get 100%. Those cases, you might get really close to 100%, but if for some reason you're having to round, these our percentages here all came out perfect, right? When we divided, we didn't get any weird decimal numbers. We just got 16, 22. But sometimes you might have to round, like you might get some crazy number like 32.376%, right? And if you do that and you round, you might not, when you add up all your percentages in this column, you might get something really close to 100%, but it won't be exact. Okay, so don't let that flip you out. But it should be really close to 100% if not exact if you didn't round. When you think of the word, questions about any of this so far? When you think about the word cumulative, what does that mean? If I accumulate something, I'm gathering a bunch of stuff, right? When my kids were little, we used to try to, right before Christmas time, go through their rooms and clean out and say, you have to donate some toys, you know, you can't keep, because it just, you accumulate more and more stuff, right? So when you think of the word cumulative, you think of, let's accumulate some stuff, okay? So what they're doing is adding on. So they're saying, okay, well, the A's were 16%. But if I add on the B's, to get this column right here, I'm going to take my 16% plus my B's, which is the 28%. So I'm going to do 16 plus 28. And I'm going to get 44. So cumulative, that, so this 44% is really saying yes. Yes. Mm-hmm. That's exactly right. Yes, perfect. So when I'm saying 44%, that's really telling me A's and B's, right? When I do the C one, I'm going to take my 44 that I had above plus whatever the number of C's I had, or the percentage of C's. So 44 plus 36 is going to get me my 80%. So 80% of my students made C's or above. That's what my cumulative frequency, as I accumulate them, that's what my cumulative frequency is telling me here. Then I'm going to take my 80 and I'm going to add on how many people made D's, the 12%. So 80 plus 12. So 92%, if we talk about pass, right? If you had to make a D or above to pass, 92% passed. We add on our last category, our F's, which was our 8%, that should get us up to 100, because that should include everybody, all the totals, right? Okay. Questions about any of that stuff? That can be a little bit confusing, but that's what cumulative frequency means. You're adding on, you're taking that category, adding the next category, and you just keep on going until you get to your 100%. Okay. Questions? Okay. I kind of think that now looking back that the speaker may be not working because of the way that this is hooked up to that, and it's trying to go through there and it's not working. So I might have to do that next class. But anyway, the videos are there if you want to see those examples. Okay, so another thing we talked about in Project 2 was the difference between qualitative data and quantitative data. Okay, qualitative data is that kind of data that you get words for answers, like what's your favorite color, or what's your favorite restaurant, or what's your favorite art musician. Okay, that's qualitative data. You don't get numbers for answers. So it describes qualities or characteristics. What color eyes do you have? Describes qualities or characteristics. I'm just going to say non-numbers. Okay, quantitative data is whenever we can measure it with numbers, right? So this definition is a little bit long, but it's the value of so a value of data in the form of counts or numbers, where each data set has a unique numerical value associated with it. So if we were doing a survey in this class and I was doing it by how tall are you? Well, that's got a number associated with it. What's your shoe size? That has a number associated. That's quantitative data. How many or one of the things on the examples they gave on our project 2 was what's your average cell phone bill? That's going to give you a number. Quantitative data is a number. And on your project, you want to, the question that you ask people needs to be a number, right? Don't do a qualitative data because that's not what, it's going to be really hard because you can't find the mean or any of that stuff of it, okay? So here's some examples, and it's asking you to choose, are these quantitative or qualitative? Brand names of shoes, and because that's going to be qualitative. If the answer is not a number, it's qualitative. Heights of students, it's going to be quantitative because we're actually going to get a number. Audience ratings of a film on a scale from 1 to 5, where 5 means excellent. Quantitative. We could actually get some number results with that, so that's quantitative. Questions about any of that stuff? Okay. When dealing with quantitative data categories, it is often useful to group or bin the data into categories that cover as large a range of, that's wrong, categories that cover a range of possible values. So what's a group or a bin? And we're going to talk about that, but it's a class interval. And I'll explain what that means. Basically, you have a range of a group. Range of a group. Most on your homework, they're going to tell you how big they want your bin size to be or how many classes it is. Okay, so here's how you decide on a bin size. So so I'm looking at this list of data right here. And you want to pick out your smallest number and you want to pick out your largest number. So when I don't see anything lower than 70 here, I look through this list and it looks like there's nothing smaller than 72. So there's my smallest number. And it looks like I want to also find my biggest number. I think 98. I don't see anything bigger than 98. So to figure out your bin size, you want to take a range of those numbers. So you want to take your biggest number, which is 98, minus your smallest number, which is 72. And you want to find that answer, which is 26. So we've got basically 26 numbers that we've got to deal with, a range of 26, not 26 numbers. We've got a range of 26 data points, okay? So what I want to do is I can't stick those all in the same category. Similar to when we had the A's and the B's and the C's, right? We put all the A's together. That was a bin, okay? The A's were a bin. The B's were a bin. The C's were a bin. This is different because I'm not doing this by A's, B's, and C's. I want to come up with something different. So most of the time in your problem, they're going to tell you to make each class size 5 or something like that. And I'm picking 5 here just because I know that 5 times 5 is 25, right? And it's going to be really close to 26. So that kind of makes sense to me. You don't have to pick that. They're going to tell you in the problem what you should pick. But here's what I shouldn't pick. 1. I shouldn't just go, okay, let's put all the grades in one bin. That's not, I have to divide it up some way. If we divided it into 2 groups, is that going to tell me very much about the data? So in other words, if I said, okay, tell me all the 72s through the 85s in one group and tell me all the 85s to 98 in another group, that would be 2 bins. That's not going to really help me. I need to get more precise. Okay, so there's not a right answer here on how many bins. You just need to use common sense. 1 and 2 is not enough. 3 might be okay, because then we're getting it down to compare, getting it isolated a little bit more. So I picked 5. And if you do 26 divided by 5, it doesn't come out even. It comes out to be like 5 point something. Okay, comes out to be like 5 point something. 26 divided by 5, 5.2. When it does this, you always round up. Okay, so we're going to make our bin size be 6. Always round up, so you're going to make your bin size be 6. Okay, so my very first group is going to have to start out with, what's the smallest number we said, 72? Okay, so I don't need to go down to 70. I can start at 72. That's the smallest number I have. And because I'm going up by 6, right, which is what we calculated, my next group would start at 72 plus 6, which would be 78. My next group's going to start at 78 plus 6, which is 84. Then I'm going to add 6, and that's going to be 84 plus 6 is going to be 90. I'm just adding 6 to get to the next one. I could, and then the next one would be 96. Okay, I could have picked something else. I didn't have to divide by 5, but you had to go with something. And on the My Math Labs, it's going to tell you what to divide by. On your own project, you're going to have to pick. You just need to pick something that's reasonable. You don't want to have a bin size that doesn't tell you any information. This is enough that this is going to actually give me some information about the scores in my class. I wouldn't want just 1 or 2 groups, so I picked 5. So this category is going to go from 72 all the way up to what number? Close. Yeah, because we'll want 78 to be in this bunch, right? This category, 78, will go all the way up to 83 because 84 is here. This is going to go up to 89, 95, and then this one just got, we don't have anybody, we're not giving bonus points. So we know it stops at 100, right? Okay, questions about any of that stuff? Because this is something that you're going to have to do on your project too. Okay, so then we would go through and make our frequency, or figure out how many things are in each one of these. So 76, go in this bunch, 80, 78, 76, 94, 75, 98. Let's put them all where they belong. And this is super easy, but just make sure you don't get in such a hurry that you're making mistakes, making silly mistakes that make you have to go, because if you have to start over, it's hard to find the one you missed, right? So, which I probably shouldn't have started talking, because that probably made me mess up, but we'll see. So we want to make sure that these numbers add up to 20, because that's how many we had. This first category is 9. This is 4, 4, 2, 1. Yeah, that, if you add all that up, you do get 20. I'm going to put down here total. So this is 20. This is my frequency. Okay, so if you're doing your survey, these are the answers you find. This is exactly the way you're going to go about doing this on your project. So the next thing, it also says it wants us to find the relative frequency. Sorry about that. And it wants us to find the cumulative frequency. Okay. So remember that the relative frequency, you could either write it as a fraction or a percent. So to write this as a fraction, I would say, well, the people who score between 72 and The people who scored between 72 and 77, that was 9 out of 20. You do 9 divided by 20, which gave you a percent, which is 0.45, or gave you a decimal, and then you need to make that into a percent, which is 45% by multiplying it by 100, right? Got 4 out of 20 that made a 78 to an 83. When you divide those two, you get 0.20. If we multiply that by 100, that's 20%. The 84s to 89s, same thing. 4 divided by 20 is 0.20. That's going to get me 20%. Okay, the 90 to 95s only had 2 of those. Well, that's 0.102 divided by 20, which is 10%. Okay, I only had one person that made above a 96. So that's 1 out of 20, which is 0.05 when you do 1 divided by 20, which is 5%. If I total all of these fractions up, that should be 20 out of 20, right? If I total all of these decimals up, 0.45 plus 0.20 plus 0.20 plus 1.10 plus 0.05, that should just be 1. If I total up all these percentages, what should that be? 100%, right? Okay. What about cumulative frequency? We're accumulating things, right? So the first time we've got 45%. Well, then we want to add on the next category. So this one would be 45 plus 20, which is going to be 65%. Then I'm going to take my 65 plus 20 again, 85%. Then I'm going to take, 85% plus my 10, that's going to be 95%. And then I'd add my 5% on, which should get me 100%. So that's all of my grades have been accumulated. It looks to like, and there are some things that are to gain with this. I can tell that 85% of my students made 84 and below, which is not necessarily good, right? So maybe I need to change something, what I'm doing, because I would rather it be the other way around, the higher percentage be up here, but it looks like a lot of grades are included in this 89 and below. But my lowest score was a 72, which is not bad either. So you want to take that into account if these are the things you were talking about. Okay. So I'm going to talk about questions about any of that. I'm going to talk about the next page, and then I'm going to end this for today. I'm going to finish this on Friday, and I'll post that video. But so we can use this to make bar charts or bar graphs. And it says a bar chart shows that each category with a bar whose length corresponds to its frequency or its relative frequency. So this one actually has the frequency of the grade on the left side, and it has the relative frequency on the right side, which is two different things. Okay, so we can use, y'all seen a bar chart before. Okay, so we can use that. These things are going to be important, especially when you turn in your project. It needs to have a title or a caption. Like, what is it? If you can't tell what data you're trying to explain, there's a problem. So the graph should have a title or caption or both that explains what's being shown, and if applicable, lists the source of the data. A vertical scale and a title. Okay, so that means that on your, we call this our y-axis, but this should have this should have a scale, has numbers over here, right? And it should have a, what is this talking about? This one actually has two vertical titles. It should also have a horizontal title going along the bottom as to what you're trying to compare. And then the legend, if there are multiple data sets. So I imagine that you've seen like a double bar graph where you've got maybe they're comparing, in this example, they could be comparing my class to another teacher's class, and they could have another bar that came along here and maybe had, okay, well, this teacher had this many A's, but she had this many B's, right? That you've seen a double bar graph where they would have a legend that would compare the two things, okay? They might be different colors. So this is kind of what you would want to do to make this bar graph. Have one more thing that I was going to tell you. Give me 1 second, hold on. So that's the end of the first part of 5C, part 1.